Dr. Richard Mattis explains his expertise and how the sensory properties of food affect not only food choice in individuals, but also the digestion and metabolism of certain foods in the body.
Podcasting from Dallas, Texas, I am Shireen, and this is the Yumlish podcast. Yumlish is working to empower you to take charge of your health through diet and exercise and reduce the risk of chronic conditions like type 2 diabetes and heart disease. We hope to share a unique perspective and a culturally relevant approach to managing these chronic conditions with you each week. Dr. Mattis is a distinguished professor of nutrition science at Purdue University, adjunct associate professor of medicine at the Indiana University School of Medicine, and affiliated scientist at the Monell Chemical Senses Center. Welcome, Dr. Mattis. How are you?
Very good. Thank you for having me.
An absolute pleasure. So, Dr. Mattis, could you talk to us about how you found yourself interested in public health, sensory science, and nutrition science in your work?
Sure. I started off with an interest in public health. I was drawn to the philosophy of disease prevention, health promotion, rather than the traditional medical model of treating illness. And so, just as I was beginning graduate school, the Women, Infant, and Children Feeding Program, WIC, was starting, and I thought there was a lot of promise to that. I was interested in it and thought I would go into program evaluation and focus on the efficacy of WIC. And so I started my graduate studies, but shortly in, I made friends with a psychology student who then introduced me to a professor of his teaching a course on sensory science and nutrition. And right from the beginning, I thought this is really fascinating work. It has a lot of potential for application to promote health. And so I switched stream right in the middle of my graduate studies, switched over to sensory science and nutrition, and ended up pursuing that for the majority of my career. However, about 8 years ago, the College at Purdue of Health and Human Sciences decided that they would develop public health as an option for students. And because I had a degree in public health and so on, I was asked to develop a program in public health. I did that for 5 years, and then we had a new dean who decided, gee, this is going quite well despite me, and we should convert it into a formal department. And so that happened in July of 2019. And I served as the inaugural head for 2 years, but then went on sabbatical and turned over the reins to a new head. And I'm now back largely in nutrition science and picking up on my research on the chemical senses and nutrition.
Can you help define for us when you talk about chemical senses, sensory science, what exactly does that mean?
Yeah, so the chemical senses are comprised of taste, smell, and chemical irritation. And I focus actually primarily on taste, though texture and olfactory or smell cues are impossible to separate entirely from that. So I don't deal with all of the senses. I don't deal with vision and audition much, but the senses that are turned on by chemical stimulation.
Interesting. Can you describe how the sensory properties of foods and sensory capacities of people influence nutrition?
Yeah, that question is actually very well put because there are two sides to this study. One is the food science side, and the study is called sensory evaluation, and it focuses on the chemical properties and physical properties of foods. All the chemicals that make up foods are presumably detectable, and will contribute to the impression that a food makes. However, each of us has a unique sensory system in that we are differentially sensitive to the vast array of chemicals that we're exposed to in everyday life, including in the food supply. And as a result, we all live in our own sensory world. We are each more or less sensitive to each of the chemicals that we're exposed to. So there is no such thing as good food, good wine, bad wine, and so on. It's how it hits our own unique sensory systems that determines how we perceive it and how much we like it. And so I think this is very important as we move into an era of personalized nutrition. We're going to have to recognize that not only do we metabolize foods differently and have different lifestyles, but we actually perceive them, their sensory properties, differently. And that's going to have an impact on food choice. Now, the second part of your question, how does it influence nutrition? There are two levels of that. One is that the sensory properties and the sensory capacities of people interact to determine food choice, how appealing a food is. I mean, we generally, given the option, will select foods that we like and reject foods that we dislike, and that determines the nutrient profile of the foods we actually end up consuming. But it actually is more profound than just food choice, because the sensory properties of the foods we consume also influence how we process them in our oral cavity. That is how we chew them and salivate in response to them. How they are digested in our stomach and in our intestines. How the nutrients are absorbed and subsequently metabolized in the body. So we actually have our sensory systems to allow us to detect chemical cues in the environment and to use that information to best develop a response to the likely ingestion of those foods. So, for example, if we eat a carbohydrate, if we over-secrete insulin in response to that, then we become hypoglycemic. That's not a desirable state. If we under-secrete insulin in response to that, then we become hyperglycemic. Again, not a desirable state. So the sensory property allows us to modulate the physiological response to the ingestion of foods, to anticipate their metabolic consequence and adjust appropriately. So it's really at two levels that sensory systems influence nutrition: food choice and metabolism.
Interesting. And so what you're saying about the latter is it's really our body's response to that is triggered by some of these tastes that we have that then triggers the insulin secretion.
Yeah, exactly. Just putting something sweet in your mouth will stimulate the release of insulin within 2 minutes. Usually, in fact, it peaks 2 to 4 minutes. So it's a neurally based, physiologically response to sensory stimulation. And that initial rise in insulin is highly correlated with the postprandial or the post-ingested rise of insulin.
Interesting. And so what kinds of taste qualities tend to have positive and negative effects on energy balance in the body?
That's a very good question, but not a straightforward answer. And the reason is we are born with certain proclivities. Most humans are attracted to sweetness and to saltiness. Now, it takes a little time for the saltiness to develop, maybe 4 to 6 months before we are responsive to salt. But once we are, it is a preferred sensation. In contrast, bitterness is inherently unpleasant. Sourness is a little more ambiguous, but usually considered unpleasant. And then there are some other sensations that are less well defined, such as umami or fatty, and how we respond to them. So there's a bit of a spectrum from pleasant to unpleasant. However, the appeal of foods is determined much more by our lifestyle, our dietary experience, our exposure to those food chemicals and those sensory qualities. So there's an old saying, as far as I can determine, first enumerated by Kurt Lewin in 1943, and that is that we like what we eat more than we eat what we like. So we may be born with certain likes and dislikes, but through life, through exposures, those are modified. And as a result, we can learn to like foods with bitter notes. And indeed, coffee, chocolate have distinct bitter notes. Wine, they have distinct bitter notes. And even though that is an aversive signal in and of itself, in the matrix of a food, we can learn to like it. Similarly, there may be foods that sweetness may be inherently pleasant, but would be inappropriate in that food. We don't generally add sugar to meat, for example. So we learn context and acceptability through culture, through exposure.
So I like this sort of correlation between the taste and the health and the body's response there. Can the effects of these taste qualities be manipulated in a way to improve health?
That's the big public health question. There's the interface between sensory science, nutrition science, and public health. There is evidence, in my opinion, compelling evidence, that we can modulate the preferred level of saltiness in the diet by manipulating the exposure to salty foods. It's been shown that if one is placed on a reduced sodium diet and the amount of sensory exposure to sodium is also reduced, then we track down and actually come to prefer foods with lower saltiness. Similarly, if we add sensory exposure to saltiness, for example, there's a very famous study by Mary Bertino and Gary Beecham from the Monell Chemical Senses Center, where they had people increase their salt intake in capsules, so it avoided the sensory exposure, but increased sodium intake, or increase sodium by salting their food very heavily. So both groups were taking in the same amount of sodium, of salt, but one group got the sensory exposure, high sensory exposure, and the other did not. And it was only in the group that had high sensory exposure that they actually tracked up and came to prefer foods with higher salt content. So it's called the hedonic shift, or the palatability shift. And it can work in both directions. We can train ourselves to prefer lower salt foods or train ourselves to prefer higher salt foods. This has been expanded now to fat. There's less evidence, but the evidence that does exist shows the phenomenon works the same way, that it is not the metabolic challenge. It's not the amount of fat actually in the diet. It's the level of exposure to fat that determines the preferred fat level of our diet. And there is work going on presently to explore the effect of the hedonic shift with sweetness. It's very difficult to manipulate sweetness independently because it is ubiquitous in the diet. And early evidence would suggest it may not act quite the same way that salt and fat. For salt and fat, the shift is in palatability, but not sensitivity. By limiting exposure, you don't become less or more sensitive to the sensation. You just interpret it differently. You like it less or more. With sweet, the very preliminary evidence suggests that there's actually a change in sensitivity or really intensity ratings for sweetness with less of an impact on hedonics or palatability. But the data are very preliminary now, and the trials are underway, so we shall see. So this is an approach that people can use to modify the preference for salt, fat, and sweet in the diet, and as a result, presumably the intake of those food ingredients. I will note that while I believe that, for example, fat replacers and salt substitutes and low calorie sweeteners have a very important role in modulating intake of those three food ingredients, their use will block this hedonic shift approach. Because if you maintain that level of sensory exposure through a low calorie sweetener, for example, you won't come to prefer lower levels of sweetness in the diet. Now, by substituting low calorie sweeteners for nutritive sweeteners, for sucrose, you may actually reduce energy intake and sugar intake, and those are desirable. It's just it will work by a different mechanism.
I see. So the impact is not really on the modulation. It's just we're just substituting it out, but we're keeping the same. Got it.
Exactly. Yeah.
Yeah. So you mentioned fat in particular. How is the sensation of fattiness detected, and what are its health implications?
So this is a very, very exciting and controversial time in sensory science. The prevailing view is that the sense of taste is a very limited sense, that it is only capable, or it's comprised of only a limited number of primary qualities. And most people agree on sweet, sour, salty, bitter, and more recently, umami. The question of whether there is actually a true taste for fattiness is an active area of research now. The view until quite recently was that we could not detect fat by taste. Instead, it was mouthfeel, that dietary fats contribute creaminess and viscosity and mouth coating and more tactile type qualities. And we do know that free fatty acids have a very distinct olfactory or smell component. That's the smell of rancid oil. But the question is there really a taste dimension to it as well? And so recent studies have attempted to control for texture and for smell and see if oral exposure to fatty acids elicits a response. And to date, there's evidence that when those controls are put into place and a fatty acid is put in the mouth, there is an abrupt rise in triglyceride levels. And it's believed that that sensory signal mobilizes lipid, fat, stored in enterocytes, the cells of the intestine. And so you get this immediate spike in triglycerides in the blood. It's short term, it goes up, it goes down, and it's not dramatic in size. But just like I described with insulin, it is correlated with the magnitude of the post-ingestive or the post-absorptive rise in triglycerides 2 to 4 to 6 hours after a meal. And so it may well be a regulatory signal that modulates triglyceride levels after an eating event. There's also evidence, we don't have a lexicon for fatty sensations. When we say sweet, we all think that we're talking about the same sensation and we all can relate to that. But there is no similar vocabulary for fat sensations. And so to demonstrate that it is a unique sensory quality, because if fats just tasted bitter, it would just be a bitter stimulus. If it tasted sour, it would be a sour stimulus. So to be a primary, it has to have a unique quality. So you can do studies where you have people sort solutions that have sweet, sour, salty, bitter, umami, and fatty chemicals in them, and see if they put the fatty ones in a separate group from all the others. So it doesn't require any vocabulary, but it allows people to show that, yeah, I can discriminate this and it's different from all the others. And when you do that study, indeed, fatty acids are unique. So it appears that, and of course you're controlling for viscosity, for texture, and for olfaction, for smell when you do these trials. So in my opinion, the literature is suggestive that indeed fat certainly has a tactile component, certainly has an olfactory component, but also has a taste component. But that's something that more research and probably a few decades of study will be required to change people's minds about the role of taste.
How can understanding the effects of sensory properties of food help people improve their diet? So if I'm someone out there who's listening who has a little bit of a sweet tooth and is trying to figure out how to improve our diet, what can be done from the effects of sensory properties level to really be able to make that positive impact?
Yeah, two approaches come to mind. One is the one we just talked about, that is by inducing the hedonic shift. And so if one would like to try that approach, then what's necessary is to purposely restrict the frequency of exposure to the sensory quality you're trying to manipulate. So if you're really trying to cut back on sodium, then you have to very consciously, purposely restrict your frequency of exposure to salty foods. And it takes about 8 to 12 weeks of that dietary restriction before this hedonic shift actually starts to manifest. And so one can come to prefer, just as a common experience, maybe it's only my generation, but there was a time when people only drank whole milk. And then there was concern about the fat level of milk, and skim milk was promoted. And this was a very clear example that people could actually come to prefer, through repeated exposure, skim milk over full fat milk. There may be an inherent liking for higher fat levels, but you can learn to actually prefer skim milk. Now, having said that, if you go through this exercise and learn to prefer skim milk, that's great, that's fine. But you have to be ever vigilant, because if you allow yourself to be exposed to high fat foods again, you can just as easily track up and come to prefer higher fat levels again. It's not that once you've retrained, you're there for life. It is an ongoing process. This is a sensory system that is designed to help survival. We have to learn to like the available food supply, and that changes, season to season, year to year. If we were only willing to eat sweet foods, for example, and winter came and there weren't sweet foods available, we would be in trouble. So we have to learn to like the food supply, and this sensory training, this hedonic shift, is a mechanism for that. The second answer I would give to that question is that it may be as exciting as a bag of nails, but I think the best nutritional advice is still balance, moderation, and variety. The sensory properties of foods can be a guide to achieving that. If we avoid excessive consumption of just sweet foods or salty foods or high fat foods, and use sensory signals as a guide to balance our intake of those foods, I think that it will help improve the variety of the foods we eat, and as a result, the nutritional balance of our diet and its healthfulness.
That is so interesting. With that, Dr. Mattis, we are toward the end of the episode. How can our listeners connect with you and just learn more about your work?
Well, sadly, I don't participate in any of the modern electronic means other than email. So if you want to email me, I can respond to that.
Yes, absolutely. So if you have a website, email, anything that you can share with us.
Yeah, it's just Mattis, Mattes, at purdue.edu.
Lovely. And so with that, Dr. Mattis, thank you so much for coming on the episode. To our listeners out there, question to you, head over to our Facebook, our Instagram to answer this. How much do sensory factors such as taste and texture influence your food choices? So we're hoping Dr. Mattis made you think about the taste, made you think about some of those sensory factors. And if you are thinking about it, join us on Facebook, on Instagram at Yumlish on Facebook, at Yumlish _ on Instagram, and let us know again, how much do sensory factors such as taste and texture influence your food choices? We will see you there after the episode. And with that, Dr. Mattis, thank you again for your time.
Yeah, my pleasure. Thank you.
Thank you for listening to the Yumlish podcast. Make sure to follow us on social media at Yumlish _ on Instagram and Twitter, and at Yumlish on Facebook and LinkedIn for tips about managing your diabetes and other chronic conditions, and to chat and connect with us about your journey and perspective. You can also visit our website, yumlish.com, for more recipes, advice, and to get involved with all of the exciting opportunities Yumlish has to offer. If you like this week's show, make sure to subscribe so you can hear more from us every time we post. Thank you again, and we'll see you next time. Remember, your health always comes first. Stay well.